On June 6, 1944, at 2:03 p.m., Sergeant Thomas Burkhardt crouched in a bombed French barn near Omaha Beach. The 4th Armored Division's maintenance bay recorded 17 Sherman tanks, inoperative that afternoon. German 88mm anti-tank guns had penetrated standard Sherman armor at ranges exceeding 100-200 yards. Burkhardt wiped grease from his hands, listening to artillery thunder across the bocage. Outside, a disabled M4A1 Sherman sat with its turret ring cracked. 3rd tank loss in 4 hours. The division's after-action reports would later note critical armor inadequacy against Panzer IV and Panther tanks. Burkhardt studied a pile of salvaged track links, damaged bogies, and steel plating. His crew worked without orders, welding scrap metal onto vulnerable hull sides. No manual authorized this modification. The improvised shields weighed approximately 800 pounds per tank. Records showed the idea emerged from field necessity, not engineering headquarters. By nightfall, 3 Shermans carried the additional armor into combat. The war would not wait for official approval. June 6, 1944 marked the Allied invasion of Normandy across 5 designated beach sectors. Sergeant Thomas Burkhardt, 4th Armored Division, operated from a makeshift repair station in a damaged barn 2 miles inland from Omaha Beach. His role involved maintaining Sherman tank operational readiness under combat conditions. Each morning began with damage assessment as tanks returned from forward positions. Oil-stained tools, inadequate spare parts, and compressed repair schedules defined the work. German defensive positions employed anti-tank weapons with demonstrated effectiveness against Allied armor. Burkhardt examined a torn transmission housing, calculating repair time against the division's operational tempo. Sherman tanks returned with penetration damage, track failures, and engine malfunctions. Between German PaK-40 anti-tank guns and the appearance of Tiger I tanks, the M4 Sherman's vulnerabilities became quantifiable. Divisional records indicated armor penetration rates exceeding pre-invasion estimates by 40%. Corporal William Harris approached carrying a damaged turret traverse mechanism. "Another one down, Burkhardt," he said, placing the component on the workbench. "Crew bailed out near Veerville. Tank's salvageable but needs 8 hours minimum." Burkhardt nodded, marking the repair log. Another Sherman disabled meant reduced offensive capability for their battalion. They possessed neither time nor resources to manufacture invulnerability. The work continued through darkness, grease and sweat marking their fatigues. Portable generators powered welding equipment, while artillery flashes illuminated the Norman sky. The barns smelled of burnt metal, diesel fuel, and cordite residue carried on the wind. By 2200 hours, 3 mechanics worked on separate tank systems simultaneously. Private Jensen torqued suspension bolts, while Harris reconnected hydraulic lines. Burkhardt reviewed damage reports, calculating material requirements against available inventory. The mathematics remained unfavorable. Supply shipments from England arrived irregularly, delayed by channel weather and logistical bottlenecks. The sound of tank engines idling outside mixed with distant small arms fire. Each repaired Sherman represented continued operational strength. Each disabled tank reduced their combat effectiveness by measurable percentages. Burkhardt understood the equation clearly. His role involved extending mechanical lifespan under conditions that accelerated component failure. The work was neither glamorous nor officially recognized, yet combat operations depended entirely upon it. The following morning, Burkhardt surveyed the repair yard as dawn illuminated 12 Sherman tanks in various states of disrepair. The M4 Sherman's design specifications prioritized mobility and production speed over armor protection. Its frontal armour measured 51mm at optimal angles, adequate against German 50mm guns but vulnerable to 75mm and 80mm weapons. Combat reports from Italy had documented this limitation extensively. Private Jensen worked near a Sherman that had absorbed a direct hit to its right sponson. The crew had evacuated successfully before fire reached the ammunition storage. Jensen cleaned the damaged area, assessing structural integrity for potential repair. "We can patch the hole, but it won't stop another 88, Jensen said, measuring the penetration diameter. "We need thicker armor." Burkhardt considered this while examining salvaged materials accumulated near the barn. Allied supply chains prioritized ammunition and fuel over replacement armor plate. Scrap metal from destroyed vehicles, damaged equipment, and battlefield debris collected in irregular piles. Standard procedure called for returning salvage to rear depots, but transportation capacity remained limited. An idea formed based on observed battlefield patterns. German anti-tank rounds typically struck Sherman hulls at predictable angles and locations. Additional armor at these impact points might deflect or absorb sufficient energy to prevent penetration. The concept required no new materials, only creative application of existing scrap. "I've got an idea," Burkhardt said, walking toward the salvage pile. He selected sections of tank track, damaged bogie wheels, and steel plating removed from irreparable vehicles. The components possessed no individual value, but collectively represented potential protection. He would make them functional. Harris joined him, understanding immediately. "Field modification?" "Supplemental armor," Burkhardt replied. "We weld scrap onto the hull sides. It adds weight, but if it stops one round, it's worth it." No manual covered this procedure. No authorization existed for modifying tank armor in field conditions, but Burkhardt's responsibility involved keeping tanks operational, and operational tanks required surviving enemy fire. The logic appeared sound. Records later showed similar modifications emerged independently at multiple repair stations during this period, suggesting parallel problem-solving under identical pressures. By 1800 hours on June 7th, welding torches illuminated the barn interior. Burkhardt and his crew worked methodically, cutting salvaged steel into sections approximately 18 inches square. Each piece was examined for structural soundness, cracks, or excessive corrosion. They selected the best materials, discarding components too damaged for effective protection. The improvised armor required secure mounting to withstand both combat stress and vehicle movement. Burkhardt designed a bracket system using salvaged bolts and steel angle iron. The brackets attached to existing hull fittings, distributing weight across structural members. Each shield section weighed between 40 and 60 pounds, depending on thickness. The crew positioned the first shield on a Sherman's left sponson, where German anti-tank rounds most frequently struck. They welded brackets at 4 points, ensuring the additional armor stood approximately 3 inches from the original hull. This spacing created an air gap that might dissipate some impact energy. The theory remained unproven, based on Burkhardt's understanding of armor ballistics rather than engineering calculations. "We'll test it on the next tank going forward," Burkhardt said, inspecting the weld quality. "If it fails, we remove it. If it works, we replicate the design." The work continued through the night. Each shield required precise placement to avoid interfering with hatches, vision ports, or track operation. The crew measured carefully, marked positions, and welded with attention to structural integrity. By dawn on June 8th, 3 Sherman tanks carried the experimental armor, concentrated on hull sides and front glacis points. Tank commanders received brief explanations of the modification. Most expressed skepticism, but accepted the additional weight as acceptable risk. Operational orders required their immediate return to forward positions. The improvised shields would face combat testing within hours. Burkhardt recorded the tank identification numbers and shield configurations in his maintenance log. No official documentation existed for this modification. If the shields failed catastrophically, responsibility would fall entirely on him. If they succeeded, the improvement might save lives. The mathematics seemed favourable. He wiped grease from his hands and watched the 3 Shermans depart toward the sound of artillery. Combat reports from June 8th indicated heavy German resistance near Carrington. American forces encountered Panzer IV tanks and extensive anti-tank gun positions. The 3 modified Shermans entered combat at approximately 0930 hours as part of a 12-tank assault on fortified positions. At 11:45 hours, radio traffic reported 1 modified Sherman struck by German 75 mm to fire. Burkhardt listened to the transmission, waiting for damage assessment. The crew reported penetration of the improvised shield, but not the main hull armor. The tank remained operational. Burkhardt exhaled slowly, documenting this result. By 1400 hours, the damaged Sherman returned to the repair station. Its left side shield showed clear impact deformation where a German round had struck. The projectile had penetrated the improvised armor, but lost sufficient energy that it failed to breach the main hull. Scorch marks and metal fragments told the complete story. The tank commander, Lieutenant Morrison, climbed down and approached Burkhardt. "Your scrap pile just saved my crew," he said. "Round would have gone straight through without it." Burkhardt examined the damage closely. The spacing between shield and hull had functioned as designed, allowing the projectile to expend energy across 2 barriers rather than 1. The concept worked, though not perfectly. The shield required replacement, but replacement cost nothing except salvaged materials and labor time. Word spread rapidly through the division. Tank crews requested similar modifications. Burkhardt's crew worked continuously, fabricating shields from salvaged materials and installing them on returning tanks. Each installation required approximately 6 hours of work, including cutting, fitting, welding, and inspection. By June 10th, 17 Sherman tanks carried improvised armor. Burkhardt refined the design based on combat damage patterns, increasing thickness at frequent impact points and reducing weight where hits rarely occurred. The shields evolved through practical testing rather than theoretical engineering. Supply officers took notice. Captain Richardson visited the repair station, examining the modified tanks. "Is this authorized?" he asked. "It's necessary," Burkhardt replied. "We're losing tanks to 75mm and 88mm rounds. This helps." Richardson studied the welds and mounting brackets. "Continue," he said finally. "Document everything. If higher command objects, I'll handle it." Over the following week, the improvised armor became standard practice at Burkhardt's repair station. Combat reports indicated modified Shermans experienced 23% fewer crew casualties when struck by anti-tank rounds compared to unmodified vehicles. The statistics remained unofficial but compelling. Burkhardt worked 18-hour days, supervising shield fabrication while maintaining regular repair schedules. His crew expanded to include 6 mechanics, all trained in the welding and fitting procedures. They developed efficient production methods, pre-cutting standard shield sizes and standardizing bracket configurations. Materials became the limiting factor. Salvaged steel supplies fluctuated based on combat intensity and battlefield recovery operations. Burkhardt submitted requests for damaged German tank hulls, which provided excellent armor plate when cut into sections. Supply officers approved these requests, recognizing the armor's effectiveness. The shield's weight affected tank performance measurably. Additional mass reduced maximum speed by approximately 2 miles per hour and increased fuel consumption by 8%. Tank commanders accepted these trade-offs readily, preferring slower protected tanks to faster vulnerable ones. German forces adapted tactically. Intelligence reports indicated enemy gunners began targeting track systems and turret rings rather than hull sides. The improvised armor provided no protection against these vulnerabilities. Burkhardt recognized this limitation but could do nothing to address it with available materials. On June 15th, a modified Sherman absorbed 3 separate 75mm hits during a single engagement near St. Lo. All 3 rounds struck improvised shields, which prevented hull penetration but were destroyed. The crew survived without injury and returned the tank for repair. Burkhardt's team replaced the shields within 7 hours, and the tank returned to service. This incident appeared in divisional after-action reports, bringing official attention to the field modification program. Engineers from 8 Corps headquarters visited on June 18th, photographing the shields and interviewing Burkhardt about design rationale and effectiveness data. "We're calling them expedient armor," the senior engineer explained. "Other divisions are doing similar things. We're collecting data to standardize the best practices." Burkhardt provided his maintenance logs, damage reports, and design sketches. The engineers departed with promises of official recognition and possible supply allocations for shield materials. Burkhardt returned to work, unconvinced that bureaucratic approval would arrive faster than German shells. By late June, the Normandy campaign's intensity escalated. German forces committed Panther tanks with 75mm high-velocity guns capable of penetrating Sherman armor at ranges exceeding 2,000 yards. Allied tank losses increased despite tactical adaptations and improved coordination with infantry and artillery. Burkhardt's shields provided measurable protection against Panzerthafer and earlier German tanks, but proved inadequate against Panther guns. Physics dictated the outcome. High-velocity armor-piercing rounds carried too much kinetic energy for improvised barriers to stop. The crew documented several instances where Panther rounds penetrated both shield and main armor, destroying tanks completely. These failures weighed heavily on Burkhardt. Each destroyed tank represented his design's limitation. He understood the shield's capabilities, but felt responsible when they proved insufficient. Harris found him one evening studying penetration patterns on a destroyed Sherman. "You can't stop physics," Harris said quietly. "The shield works against what it was designed for. Panthers are a different problem." Burkhardt knew this logically, but struggled emotionally with each failure. The improvised armor saved lives and specific circumstances, but created no illusions of invulnerability. War operated on probabilities rather than guarantees. Combat operations continued relentlessly. The division pushed towards St. Lo through bocage country, where hedgerows provided German defenders with excellent concealment and fields of fire. Tank versus tank engagements occurred at closer ranges, where shield effectiveness improved. On June 24th, Burkhardt's station received 14 damaged Shermans in a single day, the highest number since the invasion began. Half showed shield damage from successful deflections. The other half had suffered track damage, turret hits, or engine failures unrelated to armor protection. The crew worked through the night, replacing shields, repairing suspensions, and swapping damaged engines. By 0400 hours, exhaustion affected work quality. Burkhardt ordered a 4-hour rest period, the first in 3 days. The mechanics slept on benches, using spare uniforms as pillows, while artillery rumbled continuously in the distance. At 0800 hours, work resumed. Supply trucks arrived with replacement tracks, engine parts, and, unexpectedly, 60 sections of 12mm steel plate specifically allocated for shield fabrication. The 8 Corps engineers had delivered on their promise. Burkhardt's improvised solution had received official material support. The arrival of standardized materials allowed more systematic shield production. Burkhardt established an assembly line process, cutting stations, bracket fabrication, welding, and quality inspection. Production capacity increased to 4 complete shield sets per day, enough to modify every Sherman passing through for maintenance. Tank crews began requesting specific shield configurations based on their tactical roles. Reconnaissance tanks received lighter shields to preserve speed. Assault tanks received maximum protection despite weight penalties. Burkhardt accommodated these requests when possible, treating each tank as an individual engineering problem. On July 3rd, a Sherman commanded by Lieutenant Schaffer absorbed an 88mm hit to its frontal glacis. The round struck the improvised shield at an oblique angle, deflecting upward and detonating against the turret face without penetrating. Schaffer reported minor injuries from spalling, but no crew fatalities. The tank remained operational. This engagement represented the shield's most impressive documented success. An 88mm gun could penetrate 100mm of armor at standard combat ranges. The deflection resulted from angle, shield positioning, and considerable luck. Burkhardt understood not to expect replication, but the incident demonstrated the shield's maximum potential. German forces launched a counterattack near Hill 192 on July 11th, committing multiple Panther tanks and infantry supported by artillery. American forces engaged in sustained combat over 72 hours. Burkhardt's station operated continuously, receiving damaged tanks, performing field repairs, and returning them to combat often within 12 hours. During this period, Burkhardt slept 4 hours total. Coffee and determination sustained him through endless repair cycles. His hands developed permanent tremors from welding torch vibration and fatigue. Harris forcibly ordered him to rest after observing mistakes in weld placement. "You're no good dead from exhaustion," Harris said. "Sleep 6 hours, or I report you to the captain." Burkhardt complied reluctantly, sleeping in the barn office while repair work continued. He woke to reports of successful counterattacks and declining casualty rates among modified tank crews. The shields had contributed measurably to tactical success during critical operations. By July 15th, divisional records indicated 43 Sherman tanks carried improvised armor. Survival rates for these vehicles exceeded unmodified tanks by 18% when accounting for combat intensity and engagement frequency. The data vindicated Burkhardt's approach, though official recognition remained absent. On July 18th, Burkhardt's own crew faced direct combat. German forces infiltrated American lines near Perrier, threatening rear area facilities, including the repair station. Burkhardt armed himself and his mechanics with M1 Garand rifles, preparing to defend their position. Artillery fire struck within 200 yards of the barn. The mechanics moved repaired tanks into defensive positions, creating improvised fortifications using damaged hulls and equipment. Burkhardt positioned himself behind a Sherman they had modified 2 days earlier. American infantry counterattacked at 1400 hours, supported by tank destroyers and artillery. The German penetration collapsed within 3 hours. Burkhardt's position never engaged enemy forces directly, though they remained at combat readiness throughout the engagement. The experience provided visceral understanding of conditions his shields were designed to mitigate. That evening, examining the Sherman he had sheltered behind, Burkhardt noticed how the improvised armor created psychological as well as physical protection. Tank crews fought more aggressively, knowing additional protection existed. This confidence translated into tactical effectiveness, though no metric could quantify the relationship. He discussed this observation with Captain Richardson during a supply coordination meeting. Richardson nodded thoughtfully. "Morale is a combat multiplier," he said. "If the shields make crews feel safer, they perform better. That's worth something beyond the armor's physical capabilities." This perspective reframed Burkhardt's understanding of his work's value. The shields provided measurable ballistic protection, but their psychological impact on crew confidence might equal or exceed the physical benefits. Combat effectiveness derived from both material and mental factors. Meanwhile, Allied forces prepared for Operation Cobra, the breakout offensive from the Normandy beachhead. Burkhardt received orders to modify maximum number of tanks before the operation commenced. His crew worked at absolute capacity, installing shields on 52 Shermans over 5 days. The work quality remained high despite compressed schedules. Each shield received proper inspection and testing. Burkhardt refused to sacrifice reliability for speed, knowing combat conditions would stress the modifications severely. On July 24th, the eve of Operation Cobra, Burkhardt surveyed the assembled tanks. Rows of Shermans, each bearing improvised armor, represented months of accumulated experience, adaptation, and determination. Tomorrow they would face the ultimate test. Operation Cobra commenced on July 25, 1944, following massive aerial bombardment of German positions. American armored divisions attacked through the created gap, exploiting breakthrough toward open country beyond the bocage. The 4th Armored Division committed its full strength, including all modified Shermans. Combat reports flooded the repair station. Burkhardt monitored radio traffic, tracking tank positions and damage reports. The modified Shermans engaged German armor at unprecedented intensity. Several absorbed multiple hits while maintaining operational status. Others suffered catastrophic damage from Panthers and Tigers that no improvised armor could prevent. By July 27th, the division advanced 12 miles, the deepest penetration since D-Day. Tank losses remained substantial, but below pre-invasion projections. Modified Shermans showed 31% better survival rates than unmodified vehicles during comparable engagements. The statistical difference was significant and documented in official after-action analysis. On July 28th, Lieutenant Morrison's tank encountered a Panther near Coutances. The engagement occurred at 800 yards, optimal range for German gunnery. The Panther fired first, striking Morrison's Sherman on the left sponson. The improvised shield absorbed partial energy, and the round penetrated but failed to detonate ammunition storage. Morrison's crew returned fire successfully, destroying the Panther with 3 shots. Morrison survived with minor injuries. His after-action report credited the improvised armor with preventing crew fatalities and ammunition explosion. This report reached 8 Corps headquarters, where senior commanders took notice of field modification effectiveness. During Operation Cobra's first week, Burkhardt Station received 27 damaged tanks. Repair times averaged 16 hours per vehicle, including shield replacement when necessary. The crew worked without pause, sleeping in shifts, eating while working. Coffee and determination sustained operations. German resistance collapsed on August 1st as American armor broke into Brittany. The Normandy campaign's character changed from attrition to exploitation. Tank warfare became more fluid, with longer-range engagements and rapid position changes. The improvised shields continued providing protection, but tactical circumstances reduced their relative importance. Burkhardt received a letter from 8 Corps headquarters on August 3rd. It contained official authorization for the field modification program and commendation for initiative under combat conditions. The letter noted that similar programs had emerged across multiple divisions, creating informal standardization of improvised armor techniques. The cost of innovation became clear through August. While modified tanks showed improved survival rates, absolute losses remained high. American forces lost approximately 500 Sherman tanks in Normandy between D-Day and the end of August. Many carried improvised armor. The shields helped, but could not eliminate vulnerability against German heavy tanks. Burkhardt compiled casualty reports, cross-referencing crew survival rates with armor configurations. Modified tanks protected crews better during mobility kills and light to medium armor penetrations. Against heavy weapons, no meaningful difference existed. The data painted a nuanced picture of limited but real effectiveness. Each crew loss affected Burkhardt personally. He knew many tank commanders by name, had worked on their vehicles, understood their tactical preferences. When casualty reports arrived, listing familiar names, the emotional impact was significant. Harris found him one August evening sitting alone, studying a damaged shield from Lieutenant Schaffer's tank. Schaffer had died August 12th when an 88mm round penetrated his turret. "The shield did its job on the hull," Harris said quietly. "He just got hit somewhere else." Burkhardt nodded, understanding logically, but struggling emotionally. The shields addressed specific vulnerabilities, but created no comprehensive protection. War operated through probabilities, and every engagement risked lethal outcomes, regardless of preparation. By mid-August, American forces encircled German units in the Falaise pocket. Tank combat reached maximum intensity as German forces attempted breakout. Burkhardt's station operated beyond capacity, working 24-hour cycles to maintain operational readiness. Damaged tanks arrived faster than crews could repair them. On August 19th, a Sherman returned with its entire left side shield torn away by multiple 75mm hits. The crew survived because the shields had absorbed enough energy to prevent penetration. Burkhardt's team fabricated replacement shields in 4 hours, returning the tank to service before nightfall. The Falaise pocket closed August 23rd, destroying substantial German forces. American armor began redeployment toward Paris and eastern France. The Normandy campaign concluded. Burkhardt calculated that his station had modified 127 Sherman tanks over 77 days. Approximately 68 remained operational. The others had been destroyed, damaged beyond repair, or lost in combat. Those 68 represented his measurable contribution to Allied victory in France. No formal recognition arrived. Burkhardt received no medal, no promotion, no official acknowledgement beyond the 8-corps letter. His modification program became a footnote in divisional maintenance reports, documented but not celebrated. The shields themselves became standard practice, adopted informally across armoured units without attribution to their origin. This absence of recognition troubled Burkhardt less than expected. His work's value appeared in survival statistics and crew testimonials, not official commendations. Mechanics rarely received decorations. Their contribution existed in maintained equipment and operational readiness rather than combat heroics. In late August, Burkhardt received orders transferring him to a rear area maintenance depot. The division required experienced mechanics for training roles as replacement crews arrived. He departed the frontline repair station on August 28th, leaving Harris in charge of continuing shield operations. Before leaving, he compiled complete documentation, design specifications, material requirements, fabrication procedures, and effectiveness data. This information would enable other mechanics to replicate and improve the shields. Knowledge transfer mattered more than personal credit. The armor's legacy extended beyond Normandy. Similar field modifications appeared on Sherman tanks throughout the European theatre. Some units welded sandbags onto hulls, others attached concrete blocks or additional steel plating. American forces' willingness to improvise practical solutions became a consistent pattern. Historical records later noted these modifications with varying assessments. Some analysts argued they provided marginal protection at significant weight cost. Others credited them with measurable casualty reduction. Both perspectives contained truth. The shields worked within limitations, providing real but incomplete protection. Burkhardt understood this complexity. His invention was neither miracle solution nor useless addition. It represented practical response to identified vulnerability using available resources. The shields saved some lives while failing to save others. War permitted no perfect solutions. In September, working at the rear depot, Burkhardt trained replacement mechanics in shield fabrication techniques. He emphasized realistic expectations, careful workmanship, and understanding the armor's limitations. The trainees listened attentively, recognizing combat experience when they heard it. By war's end, thousands of Sherman tanks carried improvised armor modifications of various designs. Burkhardt's specific contribution disappeared into this collective effort. His shields became indistinguishable from similar improvisations developed independently by other mechanics facing identical problems. History recorded the practice but not individual practitioners. For Burkhardt, this seemed appropriate. The war continued into 1945 without Burkhardt at the front. He served in maintenance roles, training, mechanics, managing supply operations, and ensuring equipment readiness. The work remained essential but distant from combat intensity he had experienced in Normandy. Sherman tanks evolved through the war's remaining months. Later variants incorporated thicker armor, improved engines, and better crew protection based on combat experience. Some incorporated features similar to field modifications, validating improvised solutions through official engineering. Burkhardt followed these developments with professional interest. The improved designs addressed vulnerabilities he had confronted with improvised solutions. Official engineering resources produced superior results, as expected, yet his field modifications had served necessary purposes when official solutions were unavailable. He never felt heroic. His work had been practical problem-solving under pressure, not extraordinary achievement. Thousands of mechanics performed similar roles throughout the war, adapting equipment to combat requirements using available resources. The collective contribution enabled military operations despite equipment limitations. In April 1945, Germany surrendered. Burkhardt processed this news with quiet relief rather than celebration. The war had demanded everything from those who fought it. Victory meant survival, return home, resumption of peaceful life. He received discharge in June 1945, returning to civilian life in Ohio. No fanfare accompanied his return. He resumed work as an automotive mechanic, applying skills developed during military service. The work seemed mundane compared to wartime intensity, but provided satisfying purpose. Years later, Burkhardt occasionally encountered veterans who had served in armored units. Some mentioned improvised armor modifications, describing shields welded onto their tanks. Burkhardt listened, without revealing his role in developing them. The modifications had belonged to everyone who used them, not to him alone. He kept few mementos, some photographs, maintenance logs, the 8-core commendation letter. These reminded him of work that mattered during critical circumstances. The shields had been small contribution to enormous collective effort, but they had helped. That remained enough. His innovation received no lasting recognition. Military historians occasionally noted field armor modifications in Normandy, but rarely attributed them to specific individuals. Burkhardt appeared in no official accounts, received no posthumous acknowledgements. For him, this seemed appropriate. The work had been its own reward. In 1973, Burkhardt attended a 4th Armoured Division reunion. Veterans gathered to remember shared experiences and honour fallen comrades. He spoke with former tank commanders, sharing memories of Normandy's repair stations and desperate improvisations. One veteran, whose name Burkhardt had forgotten, mentioned riding in a Sherman with that junk armour welded on the sides. The veteran described how it stopped a German round near Coutances, saving his crew. He wondered who had invented it. Burkhardt smiled but said nothing. The invention belonged to necessity rather than individual genius. Dozens of mechanics had probably conceived similar solutions independently. His implementation was documented, but the idea itself emerged from shared experience under combat pressure. The reunion reinforced understanding that war's reality differed substantially from its commemoration. Official histories emphasized command decisions, major operations, and strategic outcomes. Individual contributions like improvised armor modifications disappeared into aggregated narratives about American industrial capacity and tactical adaptation. This seemed natural rather than unjust. War consisted of countless small efforts, most unrecorded, that collectively enabled documented achievements. Burkhardt's shields represented one thread in fabric woven from millions of individual actions. He never wrote about his experiences. No memoir seemed necessary. The work had occurred, had mattered in its moment, and was finished. Documentation existed in maintenance records and after-action reports for historians who cared to examine them. In later years, military history enthusiasts occasionally contacted him seeking information about field armor modifications. He provided factual responses without embellishment, design rationale, materials used, effectiveness data. The shields had been practical solutions with measurable results. Nothing more required saying. Burkhardt died in 1991, his obituary noting military service but not specific contributions. His family knew he had served as tank mechanic in Europe but understood few details. He had spoken rarely about the war, preferring to focus on present rather than past. The improvised armor shields he developed disappeared from active service decades earlier. Museums occasionally displayed Sherman tanks with field modifications, but specific attribution proved impossible. The modifications had been informal, undocumented in ways that preserved individual credit. Burkhardt's legacy existed in lives saved rather than recognition received. The distinction mattered less than the fact itself. His work had helped some survive, who might otherwise have died. For a mechanic who never sought glory, that remained sufficient achievement. The shields had done their job. So had he.